functions, evaluating functions, example of an exponential function. Next, you have trigonometric functions, and these go on forever. Be something. They have a multiple, so 2 squared is 4, times 2 is 8, 3 squared is 9, 3 times 2 is 6, times 3 that's 18, 8 minus 9 is negative 1, negative 1. Today, I want to In this video, we're going to talk about composite functions and inverse functions combined. So let's start with the basics. Using the data table that we have on the right side, evaluate this expression. What is the value of f of 2? F of 2, if we look at the function f and the x value 2, it will give us a value of 8. So f of 2 is equal to 8. Now, what is f of 8 value? Corresponds to the last two columns. Y, and it's going to give you x. So if you're trying to evaluate the inverse function, you're looking for the x value. If you're trying to evaluate a negative 0, I value is 6. Of 1. So whenever you're find the value of g of 1, we'll look for f of 3. So let's start with this. We'll look for the x value. So that's 3. The inverse function. Go ahead and find 3, and then find the corresponding x value. X value 4. 1, 3. So now you know how to evaluate composite functions that contain, well, I guess you could say inverse composite functions. In other words, in this video, we're going to talk about composite functions, how to find them, how to determine the domain of the composite function, and how to use them to test if two functions are inverses of each other. So let's begin. Let's say if f of x is equal to 1 over x, and g of x is equal to x plus 3. How can we find the composite function f of g of x? A composite function occurs when you have one function inside of another. So notice that f is written first on the left. So f is the outside part. And g is the inside part. So you can rewrite it as f of g of x. So g of x, the inside function, is the input of the function. F is the output. So to find this function, we need to take g and insert it into f. So f of x is 1 divided by x. Now, instead of writing x, we're going to replace the x with g. And in this case, g is x plus 3. So instead of writing x, we're going to write x plus 3. So that's how you can find the composite function. Now that we have the composite function, what is the domain of the composite function? What you need to realize when looking for the domain of the composite function is that the domain is restricted by the domain of the input function, not the output function. So in this particular example, we said that g is the input function, and f is the output function. Now for g of x, it's simply x plus 3. We don't have any fractions, we don't have any radicals, no logarithms. So if you have a polynomial without any fractions, the domain will be all real numbers. So the domain for g of x is from negative infinity to infinity. There's no restrictions on the input g function. It can be any other number in this and represent this. The composite function, which is 1 over x plus 3. So 1 over x plus 3, and then we need to divide by 2. So based on this, it appears as if x is less than or equal to, take into account g of x of x. And go ahead and combine these two restrictions. We see that x can't be 69, and x has to be greater than or equal to 5. So before we write the answer using interval notation, let's plot the solution on a number line. It helps if you do it that way. So let's say 5 is to the left and 69 is, and that 69 looks terrible. So this is the answer. If we subtract both sides by 2, 2 cannot equal 2x. So x cannot equal positive 1. And you can check your answer by plugging in. If you plug in 1, 1 plus 1 is 2, and 4 divided by 2 is 2. 2 minus 2 is 0. We can't have a 0 on the bottom, so x In this video, we're going to talk about how to show that two functions, f of x and g of x, are inverses each other to f minus 5. And f minus 4 of x, not this is going to be 5. Start is 5, x over function. X might be that, take away f of x. 5, so multiply the top, start back to f and g. So f and g are not inverses of each other. So here's the last example. Well, power, they will cancel, leaving behind x minus 5. And then if we add 5 to that, this will give us x. And then for g of f of x, g is on the outside, so let's start with that. And then that's x minus 5, and then insert f into g. So once again, the 5's cancel. 5 minus 5 is 0. So we're left with the cube root of x cubed. In this case, the 3's cancel. This is the same as x raised to the 3 over 3, which is x to the 1, or x. And so f and g are inverses of each other in this example. In pre-calculus, one of the most important topics that you need to know is functions, how to graph functions, how to find the domain and range. So in this video, I'm going to give you a basic understanding of the different types of functions you need to know, how the graphs look like, and also how to find the domain and range of these functions. But let's go over some basic paired functions. Let's start with the graph y equals x. Now this graph is basically a linear function. The line should pass through the origin. And for any linear function, the domain is negative infinity to infinity. The domain represents the x values that the function can have. As you can see, x can be anything. Whenever you're analyzing the domain of the function, look at the function from left to right. The lowest x value that it can have is negative infinity, and the highest is infinity. Now this function will
Alright, now question 4. Okay, super lengthy question, as you can see, takes up the whole screen, so no place to write. Anyway, so the first thing what we have to do is to find the f inverse for this function. So, well, let us get started. We have to first thing, have to scroll down a little bit. Why don't we just go all the way to 1? So minus equal to 1 over y. The curve. Okay, 1 is what we would. The previous one is the rate of f grow up again. Let's make sure it is a square bracket, okay, because, well, the x can be 0, and therefore it can take the value of 1, and therefore now the inclusive of 1, so the bracket, please make sure it is a square bracket, okay, because, well, the x can be 0, and therefore it can take the value of 1, and therefore now the domain of f inverse becomes something like this. Okay, so this shall be the answer for the first part. Now let's take a look at the second part. Let's scroll up again. It's getting from hx. The e is actually a constant, which is 2.71 something. So 1 divided by 2.71 something is actually only 0.5.